questions because probably, okay, so recording in progress, because probably you are going to be hearing about many basic concepts about AGN. So go on, the floor is yours.
Good morning, everybody. It's a pleasure to be here to talk about our research using MaNGA at the SDSS4. So I'm going to talk about our work on the relation between supermassive black holes and their host galaxies in MaNGA. And this is, I'm talking in the name of our collaborators, Rifel, Hembold, Shimoya, Ilha, Nascimento, De Conto, Gatto, Nemen, Dors. Let's see. Okay. So the outline is we'll talk about the motivation, and then I'll talk about the sample that comprise nearby AGN in MaNGA and a control sample. Then I'm talking about the stellar population and star formation rate, gas excitation, gas kinematics, and conclusions. Okay, the motivation. So we know that the supermassive black holes grow connected to the galaxy growth, and this is seen in AGN. And how is this growth happening? Via feeding processes, as the supermassive black hole feeds on the same gas that feeds star formation in the galaxy, and also via feedback processes from the AGN that can quench star formation and are needed in models of galaxy evolution to explain the galaxy luminosity function. So the group of this study is part of this bigger group that the AGN NIFS group, that we are doing studies of AGN and this feeding and feedback process using integral field spectrograph, mostly Gemini IFUs that we have done. So I begin with paper 1. Let me see if I can, I have the, my screen, I cannot see the top, just see if I can.
So yeah, we see it.
You see it, okay. Okay, let's see. Okay, so I'll be moving on, okay. So the first paper is where we established the control sample. So we found 2 control galaxies for each AGN that were matched according to Hubble type, distance, inclination, stellar mass. Most of them are low luminosity, and 30% are early type, 60% late type, a few of them interacting. So these are examples of AGN and 2 control samples for each. So how we selected it, we selected the AGN optically using the BPT diagrams and the one diagrams, the BPT diagram O3 over H beta versus N2 over H alpha. And we selected Seifert and Liners are the AGN. And we used also the one diagram to make sure that the equivalent width of the H alpha was larger than 3 angstroms, because below this threshold of 3 angstroms, we have the retired galaxies and the passive galaxies, and these are galaxies where emission lines in the nuclei can be produced by hot stars, hot evolved star post-HB stars. So, and so the AGN are in the top, and the control galaxies are in the bottom. So we see that in BPT, it seems that there are many liners, but when we look in the one diagram, these are very faint emitting galaxies that are retired and that we call liars, because they look like liners, but they are not. Okay, we did a quick synthesis of the spectrum in the SDSS3, and we could see a trend for the age of the stellar population, the mean age of the stellar population of the AGN, for a trend in the sense that the highest luminosity ones have lower mean age than the controls. Okay, so moving on to the paper 2, we looked at resolved stellar populations using the Starlight code from Sid Fernandez. And so we ended up binning the age contribution in 3 bins: the young, younger than 40 mega years, intermediate between 40 and 2,500 mega years, and then the old. So one example of this study, so we show the distributions of the contribution of young in percent contribution to the light at 5,500 angstroms. So the young population, the intermediate age, and the old population, besides the reddening and the mean age. So one example for a late type host of an AGN, we show here the AGN in red. So this is the distribution to the left, and to the right, we made like an average gradient, azimuthal average, okay? So we found in this AGN, for example, higher young and intermediate age components all around, over the whole extension of the galaxy. And as a consequence, lower contribution of old component, okay? And mean age is also lower. So the main difference that we found in this study of resolved stellar population was in the young and the intermediate age contributions. Here is to show the mean gradients for the young age to the left and the intermediate age to the right. The continuous lines are AGN, the dashed lines are the controls. And we see that they are very similar. We see in all of them, the young and intermediate age increasing outwards, the contribution. And the difference between the AGN and controls appeared in the most luminous beams. So we see more young stellar population and more intermediate age population in the only in the most luminous AGN of the sample. Okay. So what we could conclude in nearby AGN hosts, we found distinct stellar population from controls only for the most luminous AGN. For the lower luminosity AGN, we didn't find any difference. And the most luminous AGN present higher contribution of young and intermediate age stars than controls. So what we concluded from, our sample, paired sample, is that we don't see any signature of star formation quenching when you consider this control sample. On the contrary, actually, for the luminous AGN, we see more young stellar population. So one explanation that these luminous AGNs were probably triggered by a new supply of gas that also triggered recent star formation in the hosts. So for the near universe, it seems that the coevolution, the feeding is more important for the coevolution than feedback. Okay. So I'm comparing with the results from Sebastian as usual results that people argue about the stellar population and the stage of evolution of AGN as compared to other galaxies. So, so Sebastian and collaborators did this study using a sample of 98 AGN hosts, which are the stars here, and calculated the star, So they are, as our sample, Seifert and liners in the BPT diagram, and they are mostly concentrated in types, early types, and up to SC galaxy. Okay, and they concluded that the AGN are more massive, more compact, and more centrally peaked. And so it is argued that when you calculate the star formation rate, the star formation rate is in between those obtained for the red sequence galaxies and the blue sequence galaxies. So the star formation rate was obtained from the H alpha luminosity using the Kennicutt formula. And then it's argued that the AGN are in the green value. Okay, and so the mean age also is in between star forming and red galaxy, and this leads to a conclusion that the star formation is being quenched in AGN. So we have two observations here, that the Kennicutt relation is valid for star forming regions. So in AGN, maybe it is overestimating the star forming rate because it's ionized by AGN and not by stars. And our results, when we pair the galaxies, suggest that nearby AGN are not blue galaxies being quenched, but maybe red galaxies that are being, the AGN is being triggered again by new gas supply. So it's our possible interpretation for our results are compared to these other studies. Okay, we did studies of the gas excitation as well. This is a control galaxy. So in the BPT diagram, it seems to have a Cipher nucleus, but when we use the one diagram, it has all, it's a layer in the center. So it's just to show that we use these diagrams to study the excitation. And so an example of two examples of AGN and two controls. And I will answer the questions in the end, please. Okay, Sebastian. Okay, and then we have, okay, the excitation maps showing that we have Cipher nuclei, we have also layer. Mostly the controls are layer in the center, and the AGN is a Cipher or liner. Okay, so these are two examples. And we see many controls have a layer in the center. We found a relation between the extent of the ionized region by the AGN with the AGN luminosity. The most luminous have more extended region ionized by the AGN. And this is found in other studies also, like this one by Shen et al. One thing that we tried to study was the star formation rate from the gas, using, again, the same Kennicutt 98 formula, using the H alpha luminosity. But we use it only for the disks in the regions where the emission was classified as due to star formation. We did not include the liner part, the Cipher part, or the transition region part of the spaxels. So, for example, this is the AGN, and these are the region that we could measure the star formation rate. And these are the controls, okay, with the star formation rate. So I will focus on the star formation rate, that I won't have time to talk about the other distributions, because the star formation rate is more important here. And this graph is a little complicated to see, but what it says is that when we compare the star formation rate between the AGN and the control and divide by that star formation rate from the AGN, we see the following. The conclusion is the following. We see in 75% of the early type AGN, we see enhanced star formation. So there is higher star formation rate in the disk of the early type AGN than in the controls. But in the late type AGN, we don't see, just seeing 50%. So it means that the late type AGN have similar star formation rate in the disks to controls, okay? But in the early type AGN, we see enhanced star formation. So in the galaxy, in the outer parts, we don't see again quenching. We are trying to look closely to, more closely to this issue of star formation rate in AGN. And this is a work led by Rogério Riffel, where we took all these spaxels that were diagnosed as star forming spaxels from an increased sample, now 170 AGN and 300 controls. So we calculated the star formation rate from the gas using the Kennicutt formula again, and the star formation rate from stars using the starlight code. So the work of Rogério was to investigate which was the best star formation rate indicator for the stellar population. And we concluded that the best correlation between the star formation rate from stars and star formation rate from galaxy is better if you use to calculate the star formation rate only stellar population younger than 20 mega years. So we are now looking to apply these relations that we got between star formation rate from stars and star formation rate from gas and vice versa here. So we can get the star formation rate for the gas from stars that we got from this relation to apply to the spaxels that are ionized by AGN, that we cannot use the Kennicutt law. Moving to kinematics. So we investigated the stellar and gas kinematics in this paper, building symmetrized velocity fields of gas and stars using kinemetry to look for difference between the stellar and gas kinematic major axis orientations. And we didn't find any difference between the orientation of the kinematic major axis of the AGN and the control sample. So the conclusion is that the large scale galaxy velocity field is not affected by GN for this nearby AGN of MaNGA in MaNGA. Although our previous AGN studies with Gemini EFUs, when we look at in detail to the inner few kiloparsecs, we found disturbed kinematics and different axis orientation for outflows, but this is too small scale for the sampling of MaNGA. So MaNGA samples the large scale, and we didn't see difference there. The only difference we got was for the velocity dispersion. So when we compare the velocity dispersion of the gas minus the velocity dispersion of the stars divided by the velocity dispersion of the stars, compare AGN and controls, we do see a difference that the AGN tend to have higher velocity dispersions of the gas relative to the stars. So some signature of feedback of AGN on the gas, increasing the velocity dispersion. So this we found this correlation when we put the control galaxies and the AGNs as a function, the luminosity as a function of this index sigma frac, showing that the highest the luminosity, the highest the dispersion, the higher the luminosity, the higher the disturbance in the gas in the galaxy. We are studying more kinematics in this work of Lara Gatto, and we are looking at W80, which is the width of the profile of the O3 emission line that comprises 80% of the flux. So we are building these maps, but we are fitting one or two or three components to the profiles, the number necessary, and then we measure in the reconstructed profile the W80. So we see here the W80 of one AGN, and we in this case, in the AGN, we usually find in 40% of them O3 broad components, so wings actually in the profile of O3. Increasing W80. Okay, so we hope to estimate the feedback via W80 itself and also via the broad component that is very concentrated in the nucleus, as this part shows. We show the velocities that are blue shifted. So this is outflow coming towards us. and here's the control galaxy. So this is an ongoing study. And the distribution of W8 is similar to the work shown in the work by Villez-Alec, 2020. The W8 is displaced towards higher values for the AGNs as compared to controls. And here we separated the narrow components and the broad components. So the broad components,
Thaisa,
yes.
This is your 5-minute warning.
5 minutes, thank you. So the broad components is between 600 and 700. The narrow components a little bit lower, about 300. And it's even the narrow components a bit wider than the controls. The profile of O3 is wider than those of the controls. We have done also some kinematic studies. We are doing kinematic studies of these red geyser galaxies. The prototype is Akira, that has a compact radio source, and Shen et al. Found, and also Roy, who also participated in this conference, I'm not sure if he's in the audience, also found that they have all these red geyser galaxies. They have a compact radio source, a low luminosity AGN at the center, and a bipolar outflow that is seen H alpha. And they concluded that they are a prototype of about 10% of quiescent galaxies that show that maybe these outflows are suppressing star formation in what they call the maintenance mode feedback. The nucleus is very low activity, but you see these outflows extended to the galaxy. And in a paper led by Weijmans, we looked at with Gemini IFU into Akira. And I think the most important result is that we found that in the Gemini field of view, that's much smaller than the MaNGA field of view, we see also H alpha as a stream of gas, and the same, but the major axis in MaNGA is more or less north-south, and we found it tilted by 50 degrees. So there seems to be precessing. So our interpretation is that maybe there is a precessing wind from RIAF that we are catching in the ionized gas. So this is the first time that is seen in ionized gas. This was only previously seen in radio jazz. So Ilya, Gabriele Ilya is working on a larger sample of these red geysers. Finally, I would like to mention this work by Comerford, Julie Comerford, where she did a different selection of AGN and MaNGA from the spectra itself in the MaNGA that are optical selection, but look at mainly at radio sources that are radio AGN in the MaNGA sample. And she realized that there were about 300 radio sources in galaxies that are typical of AGN, but we don't see, many of them we don't see in the optical signatures of AGN. And so she found 81 that could be classified as radio quiet and 143 that could be classified as radio mode. And the radio quiet are mostly in spirals, and radio mostly radio mode AGN mostly in ellipticals. And 10% of radio mode AGN also found in mergers. So she looked again at the star formation rate, and she argued that this blue thing is the main sequence of star formation. And then the star formation rate in the AGN, these radio sources AGN, are below the star formation main sequence. And the age of the stellar population is also older.
1 minute warning.
Okay, older for the radio mode AGN, okay? So one possible conclusion is that the radio mode feedback is quenching star formation, this sample, but I'm more favor the opinion that the radio mode is the result of low accretion rates. The radio source we are seeing now is the result of low accretion rate in gas exhausted ellipticals and bulges, and probably related to radio geysers and red geysers. So I would like to finish saying that I think the strength of our studies is the establishment of this control sample. And when we compare to the control sample, we see no signature of star formation quenching the new universe. And on the contrary, we see some enhanced star formation in early type galaxies, in the most luminous one. So the coevolution is mostly due to feeding, then feedback in the new universe. And we see kinematic signatures of feedback, but maybe this is having a very mild effect, and the effect on the star formation is still to come. It's not seen now. This is what we don't see. Suppression of star formation so far. Okay, and we are doing also some study of these red geysers, and maybe this maintenance mode feedback is present also in this radio mode AGN. And this is what I wanted to tell. We have some further work being done, but I leave my conclusions, and should I stop sharing or answer questions with the conclusions up?
Thank you very much, Thaisa. I think it's fine if you keep your slides for a little bit while I read the questions. Okay. So there we have a few questions right now. I will start with one from an ECR, who's Héctor Ibarra Medel. He asks, do you know how much the non-thermal component in the luminous AGN could bias the age gradient of the galaxies?
With this luminous AGN in the MaNGA sample, we still can see the stellar population. So we put it in the nucleus a power law component for the AGN, but we are pretty confident that we are seeing this enhanced star formation. So there could be some contamination, but we concluded that, you know, when we compare with the control sample, we do see this enhanced star formation.
Okay. We have another question, but meanwhile, I ask the ECRs that have questions to please type them in. So now we're moving to the second question by Vladimira Villarriz. AGN are transitory and likely recurrent. Therefore, many MaNGA galaxies without AGN features, which are in the control samples, could have an AGN in the recent past. Did you attempt to find the presence of AGN in the recent past for your galaxy sample?
Yeah, maybe these are the ones that Dominika Vilizalek mentions, that she finds AGN signatures outside the center. So we see like AGN that have shut down. So this is what it's being mentioned.
Okay.
I think Sebastian had
yes.
raised his hand.
Yeah, sorry, but I was giving preference to the ECR and to the question that I already had in the chat. I'm sorry. Okay. So I have the last question, a question by Sebastian Sanchez. We repeated the analysis using the star formation rate using the stellar population analysis with the same results. He posted a plot in the Slack for everybody to see. And the main conclusion was not driven only by the distribution of the star formation rate stellar mass. And it was driven mostly by the radial distribution of specific star formation rate and sigma gas. And then there is a drop of both quantities in the central regions.
Okay, well, what can I say? So what has been raised here is that maybe the control sample are AGN that are off at the moment. So this could be some problem.
Okay, he just, sorry, He just typed the last sentence of his question. How rejuvenation can explain that?
So what I understand is that the star formation rate is in between the red sequence and the blue sequence. Okay, so we can either have, you know, the AGN being in star forming galaxies that are being quenched, or we can have AGN in the bulges, because even Sebastian found that the AGN are more in early types and galaxies with big bulges. So we can have like rejuvenation from gas that is being accreted, or from the outer parts of the galaxy, or from the outside. We think that for late types, maybe it's from the same galaxy. From the early types, maybe it's from outside. And we didn't find difference with the controls for the late types, and we found for the early types. I'm not sure if I'm answering the question, but well, it's what we see, and if we believe that the controls are controls, is what we are finding. Yeah.
Okay, thank you very much, Thaisa. I think we have to move to the next talk.
Okay.
But I encourage everybody to post further questions for Thaisa in the Slack. But thank you very much. I think now we can move on to the next speaker, who is Niall. Deacon, could you please share your screen now? Hi, Niall. Are you ready?
Yes, sorry. Can somebody unmute me? I was muted for a second. I was wondering if someone else could unmute me, but okay, sorry.
Okay, we are seeing your slides, but they are not in presentation mode. I don't know if you want to do that.
I'm just doing that now, so I'll take a second to come up.
Yep, I hear you just fine, Neil.
Okay, thanks. And you can see them on display. No, I'm sorry, but this didn't happen in warm up. Sorry. I'm really sorry, PowerPoint just crashed. Give me a second. I'll try again.
Yeah, take your time.
Okay, can you see my slides now?
Yes, we can see them, but we see like the screen has like a split.
Okay. How about this now?
I don't know, Jordan, are you seeing this right? Because
it looks like something has frozen or something, so that the text is messed up. Try stopping and starting again.
Okay, I'm really sorry. This didn't happen in the warm up.
I wonder if the wrong screen is being shared.
I tried that, but it won't.
Yeah.
Okay, so I think you can see the presenter slides now.
Yep.
So if I go to swap display, you now see the correct slides?
There you go.
now, yes.
Yep, looks great.
Okay, excellent.
Perfect.
Thank you. Sorry about that. This didn't happen in the warm up.
Yeah, no problem.
Okay, so just read quickly.
Okay.
Hi, I'm Niall Deacon. I'm based at MPIA. I'm the EPO Education Public Outreach Coordinator for SDSS 5. Most of my time I spend working at the IU Office of Astronomy for Education, based up the hill at MPIA in Heidelberg. So I want to start my talk with just a little brief kind of why EPO moment. Just to sort of give you an idea as to why I think that education and public outreach is important. And the first reason I wanted to mention was that communicating science involves examining our own understanding of scientific concepts. For instance, a while back, I was trying to write an explanation of the Voster-McLaughlin effect, which is an effect where you can measure the sort of orientation of exoplanet orbits, but for a kind of popular general audience. And I realized during that the little stories I told myself when I'd learned about that were actually incorrect. And it took me a little while to kind of go through and re-examine my own understanding of that concept and to try and kind of build a better way of explaining it and also improve my own understanding of that concept. So I think one reason that education and public outreach are important is that it allows us to examine how we explain scientific concept to ourselves and to others, and maybe improve our understandings of particular scientific concepts. Another reason I think it's very important is that astronomy acts as a kind of gateway subject to other STEM subjects. Astronomy is one of these kind of things that, you know, it's very popular in the media, in the arts, things like that. You know, there aren't that many songs or concept albums that are made about condensed matter physics, but in astronomy, there's lots and lots of interest just from the general public. So it's a good way to get both people in general and also students at schools and universities interested in STEM by introducing astronomy topics and concepts to them. Another reason that I think it's important is that, well, I work for the IEU, I work for one of the offices of the IEU, and the IEU's motto is all under one sky. And every person on Earth holds a stake in the research that we do on that one sky. So I think it's important that we as scientists spend time to explain what we find and to try and talk to people about their understanding of the universe and what our understanding is as well. And the final point I would want to say is science communication can be great fun. It's a great chance to kind of, you know, muck about and try nice, interesting, different ways of doing explanations. One example for me would be that I spent a couple of years running an Astronomy on Tap location here in Heidelberg, and I got to do the promotional posters. So I did things like this, just, you know, fun astronomy themed kind of posters, images that kind of hook you, very bad galaxy cupcakes, things like just trying to think of kind of fun ways to explain and communicate science using just kind of fun ways. So SDSS has a fantastic record of EPO activities. There's a huge wealth of activities using both SDSS images, plates, other kind of catalogue data. There's the Plates for Education program, which I'm going to mention a little bit later. There's also citizen science, particularly the Galaxy Zoo. I'm not going to go into that in detail because I'm not being involved in that terribly much, but well, at all. But you know, I just wanted to mention it because this is a really successful EPO project that has been done both as an EPO project and as an excellent way to improve scientists' understanding of SDSS data. There's also SDSS plates as an artistic medium, which I'll show a few examples of later. And there's also SDSS in social media. You can follow the various channels run by some of the SDSS scientists, and particularly Jennifer Johnson and Karen Masters. And yeah, their content is really, really good social media content. So I should say before I show some of the work done within SDSS, this was work that was done before I became part of the SDSS EPO team. So please don't credit me with this. Please credit the following work to the previous EPO coordinators, Lito Tuyero and Brett Lundgren. Others who are involved in these projects as well. I'll try and reference as many as I can. I'm sorry if I've not mentioned anyone's name here, but yeah, please don't credit me with the work that's been done in the next few slides. So SDSS Voyages is a comprehensive set of astronomical activities based on SDSS plates and SDSS data. You can do this with or without an SDSS plate, and it ties in with the SDSS Plates for Education in some ways. but you can also do it without a plate. And it takes students from a kind of very basic concepts of astronomical surveys involving coordinate schemes, how we map things, kind of taking things from Cartesian to spherical projection, things like that. And it goes on to introduce important concepts in kind of entry-level ideas on big data and querying large-scale scientific databases to do science and educational projects. Next, I want to mention Plates for Education. It puts used or retired SDSS plates in the hands of teachers and other educators. And it gives students both a piece of scientific history that they can kind of have something and say, this thing was used to observe the universe. And also something they can do school activities on and learn about what the different things on the plate were, what, this hole here, what was observed here, what knowledge was gained by looking through light that came through this tiny little hole. And there have been hundreds that have already been distributed with the help of SDSS institutions and observatories. Next, I want to quickly mention SDSS educational resources for undergraduate institutions. So these are primarily being built with the SciServer tool, which is hosted by JHU. I know Jordan Raddick has done a lot of work on this. And this is kind of a cloud-based platform for scientific collaboration and educational projects working on large data sets. There have been a couple of specific model lab courses developed for this. One is a series of Python notebooks developed by Rita Strugero for Astro 101 labs. If you see here, there's a link to her GitHub there that gives you the Python notebook that you can go and play with and work out how you might introduce that and the concepts used in that into your lessons. There's also a series of upper undergraduate labs that Britt has developed. So there again is her GitHub link, so please go ahead, have a look there, see if there's anything that you think you could incorporate into your undergraduate lessons, maybe even some of your graduate school lessons, so you can use SDSS data in the teaching lab. I should also mention the FAST program, which promotes collaboration with various undergraduate institutions, collaboration and involvement, I should say, with undergraduate institutions with a strong track record in serving underrepresented minority students. That was mentioned as well in Gina's talk previously. Next, I want to turn to SDSS plates as an artistic medium. Now, we have all these metal plates left over from SDSS observations, and they actually provide a really interesting medium for artists. And by medium, I mean something like marble or paint or other forms of stuff that you can use to create art. Here's an example of a nice piece called Code for Everything by Tim Fitzpatrick. Tim is the SDSS astronomer artist in residence, sorry. He's been working a lot with Anna-Marie. He has forthcoming projects involving the last ever SDSS plate. You might have seen we had a press release a while ago about the last ever SDSS plate being taken. And he's also got a few works planned for the Las Cruces Space Festival. There's one he mentioned to me about a performance art project involving trying to mimic how a radio telescope works. Sounded really, really cool. Next, there's a work by Jian Yang. This was based in China, a gallery there. I really like this piece. There was a maze in the middle of the room this was hosted in, and you can wander through the maze and you found this sculpture. And this sculpture is based on an oral tradition that the night sky is essentially an elephant. And if you can find the leg of the elephant, you can climb up and touch the stars. So you go through this maze, and then you find here this SDSS plate, which is essentially the foot of this elephant. And it's this kind of the first point of reaching up to touch the stars. And I think that's just a really nice explanation of what we do as scientists, this kind of almost kind of finding the bottom of the data is the base of how we reach up and understand the sky. This is also a work called The Space in Between by Xavier Poultney, who went through who went and kind of did some interesting work with SDSS observatories, but also went and found out about other ways of understanding the universe from Native American traditions in the Southwest, around the kind of area where the AP was based. And finally, here's another couple of works, one by Sarah Ruther, and a work called The Center is Everywhere by Josiah McElney. It's just really cool, so I just want to show them, that's why. Finally, there's a few more works of art coming up. I'd be very interested, if you know someone who's an artist who'd be interested in taking some SDSS plates and creating something interesting with them, please get in touch. This is something that we're really interested in doing, kind of large projects using large numbers of SDSS plates to basically make something interesting and say something interesting about the way that we understand, communicate about the universe. I'll now spend a little bit of time introducing myself. I spent 18 years doing science for large-scale surveys with a bunch of large-scale surveys that were not SDSS. My research interests are my stars and brown dwarfs. I've written a book about exoplanets. I'm now the coordinator at the IU Office of Astronomy for Education, hosted here by MPIA in Heidelberg. A little quick bit about where I work. My slides just crashed. Sorry about this. Can you see something now? Yep. Okay. What do you see? Okay. Slide should be back now. Sorry, I'm really sorry about that. But I think it was a font thing. That's not happened before when I practiced this. So the Office of Astronomy for Education is the IU's new office specialising in astronomy for primary and secondary education. It's hosted by MPIA. And part of our kind of initial setup phase, we've been building a series of national astronomy education coordinators. These are teams of typically up to 5 people, although a few countries have more than 5. In many different countries and territories, who basically are meant to work both with the education community in their country and also with us in developing educational resources that are appropriate for their country. We're also building a series of centres and nodes around the world. We're going to have an announcement on that relatively soon. Just quickly show you our map of National Astronomy Education Coordinators. If you see something here that is grey, we are interested in hearing from anyone in any of these countries or territories who would be interested in being a National Astronomy Education Coordinator. We're particularly interested in the Caribbean, Africa, and Oceania, where we have particularly large gaps in our network. So please get in touch with me if you know anyone who you think might be interested in being a National Astronomy Education Coordinator for any of these countries. So what we're building at the IU OEE is to take over a couple of projects. So AstroEDU is an IU repository for peer-reviewed educational activities. We've taken over the management of a large part of that, although the previous people who ran this stay in place as the kind of editorial advisory board. Same with the big ideas in astronomy. Big ideas in astronomy is kind of an idea of basically stripping down astronomy concepts to a series of very big general ideas with a series of sub-ideas as a way of explaining this to the general public. And we're also building a series of other resources, including a glossary of astronomical terms for educational purposes. And hopefully we're going to be involved with repositories for educational materials as well. This is now my appeal to you, the SDSS scientists. We've got a huge wealth of resources in English with some Portuguese and Spanish translations. We have a lot of SDSS scientists who are from countries who speak fluently many different languages. I'd be really interested in hearing from you if you'd be interested in taking these educational resources that SDSS has and translating them into other languages that you speak. Particularly, I know we've got East Asian collaborators within SDSS. So if you're interested in helping with this, please get in touch with that. Also, we are trying to distribute as many plates as we can. I know some of you have been in contact and asked about getting plates distributed. We're currently working out the logistics of some of this, but we'll be in touch soon with more details on when your plates will ship. If you'd be interested in distributing plates to local schools, please get in contact. If you know artists who might be interested in building works using these SDSS plates, again, please get in contact. We have an EPO email list. We'd be interested for anyone who would like to join that list. Additionally, we have a telecon once every 2 weeks. It's this Thursday at 11:30 Eastern Daylight Savings Time. If you have, if that time, I realise that time might not be convenient for everybody. So please get in touch if you'd be interested in joining the EPO telecon, but if you don't find this time convenient, and we'll look at ways of kind of shifting the time zone around to incorporate a broader range of SDSS scientists. And yeah, I'll just leave my summary slides up and ask for any questions.
Thank you very much, Niall. Time for questions. Of course, ECRs are encouraged to ask, and I will read their questions first. Meanwhile, I will read a question by Sarah Loveman. She wants to know if they are still available for participating institutions. Sorry, I think she's talking about the plates. Are plates still available for participating institutions for academic outreach?
Yes, plates are still available for participating institutions. For SDSS institutions, we do ask you to pay the shipping costs, but just get in touch with me if you'd be interested in taking these plates and using them for educational purposes, outreach, or also if you've been involved in a particular SDSS survey and you'd like a plate of that survey as part of your, as a souvenir of your involvement, just please get in touch and we'll be happy to work out the details and get those shipped to you.
Fantastic. Are there any other questions for Niall about EPO?
Can I ask a quick question?
Sure.
Sure.
So sorry if I missed this. Does Voyage's website figure in your plans in any way?
Yes, we'd like to try and translate that into different languages, using hopefully the assistance of SDSS scientists. I'd also be interested in seeing, this is something I haven't really discussed with the Astro EDU people, if there's any content from Voyages that could also be kind of linked to or hosted partly by Astro EDU, so it kind of gets SDSS material to an audience through another route, but I haven't really discussed that with either the Voyages people or the Astro EDU people, so I can't say that that's going to happen.
Thanks.
Thank you. I think we have time for one or two more questions. Well, otherwise we can thank Niall for his presentation. Thank you very much.
Thank you.
And now we can move on to the next speaker, who is Anne-Marie Weijmans. Anne-Marie, could you please share your screen now?
Yes, I'm going to try that.
Thank you.
Okay, if that went horribly wrong, I'm pretty sure someone will tell me.
No, I think we are seeing your screen correctly. So thank you very much. And now we have a talk by Anne-Marie Weijmans about SDSS Data 101. So I think everybody will be appreciating your talk. The floor is yours.
Okay, well, thank you very much, Marianne and Odette, for letting me talk about data, one of my favorite subjects at these meetings. So this talk is going to be an SDSS Data 101 talk. So as Odette just put in the chat, please ask any questions that you may have, please ask them there. It may actually help if you put question and then your question itself so that they can filter this out, because I will use the chat for other things too during this talk. Okay, so the plan that I have for this talk is that, of course, I'm going to talk about the data access, where is the data, how can you use it, so that you can also start thinking about, okay, this is science that I want to do, what data do I need, and how can I best interact with that? I will also talk a bit about public data releases, how these work, why we do them. And I hope to demystify some of the acronyms that you may have come across when working with SDSS data, such as SAS, GAS, VAC, and there are probably a few more. At the end, I will also go a bit into detail about what changes, improvements we're making going from Sloan 4 to Sloan 5. I will attempt some live demos, and if they fail, then that is not on the SDSS data team, then we just blame the interconnection that I have here in rural Scotland. But I will keep those very much to a minimum, because we have a data workshop this afternoon where SciSurfer, SpecDash, Marvin, and SkySurfer, which I will explain what they are, all have that particular demonstration. So if at the end of this talk you think that looked interesting, that is maybe something I want to use, please come to our data handout. And as you can see, we also have time at the end of that session where you can just ask us anything that you wanted to know about data. So please keep that in mind, and please join us this afternoon or evening. Okay. So let's dive into the data, and maybe it's good to first take a moment to take a step back and think about how much data are we actually talking about. And Joel Brownstein made this plot, which shows how the data volume has grown over the data releases that we have produced in Sloan. And I think we can conclude that we all are very good at generating lots of data. Currently, DR16 is the active data release, and that is almost 400 terabytes of data. Will go to over 600 terabytes of data when our final Sloan 4 data release goes live, DR17, and that will be in December. So just to tell you, we have data and there is a lot of it. So we have an SDSS data team, and I think it's good to know who they are, so that if you get an email from us, or if you want to get into contact with us, to know who we are and what we do. So this is a slide I show every year, and every year I update it, and I need to put more faces on them because the team is growing, which is good, but I will run out of space pretty quickly here. So Joel and Annie and I are, I think, also at this call here, and we also represent the data team in the management committee. Brian is developing lots of different software tools that I will show you a little bit more on during this talk. Jordan has been great during this meeting with keeping our Zoom groups open, but he does a lot of things like working on the SDSS websites, and he's also giving the demos later today for SkySurfer and SciSurfer together with Manu. At Johns Hopkins, we also have some assistants with database experts, Sue and Victor. This is the best picture I could find of Ben Weaver, who is triaging the help desk requests that come in. Every week we get on average 2 to 3 requests. So that is something that we also help users with to use our data. And then we also have a graduate student helping us at Utah. and Michael Talbot graduated, so Yuri. That does mean, however, that he's leaving there and he's handing over to Abigail, who is starting, I think, in September. So if you run into Abigail at some point during the meeting, please say hi to her and welcome her to the SDSS team. Now, when talking about data, I think I should first start with two of the main acronyms and what they mean. And that is, on the one hand, the SAS, the Science Archive Server. And on the other hand, it's the CAS, the Catalog Archive Server. And these two servers together is basically where the SDSS data lives. So what is the difference between them? So starting with the SAS is at the Center for High Performance Computing at the University of Utah. Sorry if you're in Utah, I did know that. And what that server stores is all the raw data products, the intermediate data products, and the reduced data products. So if you are looking for a spectrum, you will find it on the SAS. It is stored in a file system that I'll demonstrate in a moment, and you can download the spectra from there. You can download spectra one by one. You can also do a bulk download and then analyze it offline, say on your own computer or computing system. The Catalog Archive Server, or the CAS, is hosted at Johns Hopkins in Baltimore. Sky Server is an access point into the CAS. I'll also demonstrate that. And unlike the SAS, it's more of a graphical and a query-based interface. And it is mainly there to store catalogs of derived data products. So spectra themselves, you would go to the SAS, but if you then want to say, okay, but I want to have a star formation rate that was measured from the spectra, that would be in a catalog that you would find on the CAS. So during the talk, these two terms will come back again and again. So please try to keep this in mind. SAS, Utah, spectra, files, and CAS is in Baltimore at Johns Hopkins, and it's more catalogs and queries. But that being said, let's then first dive into the SAS and what it does. So as said, it's a Science Archive Server, and you can use this server here if you want to have your data files ready, and you can download them there. And just to see how this works, I am going to leave my PowerPoint for a moment, and I'm going to the data portal. And you know what, for anyone who wants to follow along, here's the link in the chat. And I will admit that this is usually where I go through, because from here I can basically dive anywhere into SDSS that I need to go, whether that is the SAS or the Sky Server, whether that is education, public outreach, like the Voyager space that Niall just mentioned, or whether that is to interact with the data. But for now, I'm going to the Science Archive Server. That is where all the data releases live. DR16 is the latest one. And I'm just going to go to MaNGA because that is the survey that I'm most familiar with. And I want to look at some, let's see some data cubes. So I go to Redux. It may be that this is just a very large directory and therefore it takes a while, because I have the feeling that we observed a lot of MaNGA galaxies in the past 5 years, but there they are. Of course, like anyone working with MaNGA data, I have my favorite plate, 7443. It's the commissioning plate. And there I can now click and download, say, the cubes. If you now think, well, that's easy for you to say because you know exactly where to go and where to navigate to find this, we have a website where for each different survey, we have documentation to tell you where to find the data. So for instance, for MaNGA, I'm just using again this as an example. There is a Getting Started with MaNGA page. There we are. And also all the surveys have a list of tutorials that you can go through. So I'm just also going to copy this one in the chat if you want to have that link. Okay, So that is where to go my data. I can now download it. I can also do a bulk download. And again, there is a website in my slides, which will also go online for you to find. But that doesn't tell you yet, okay, but what actually is in that file? So every file that we every data product that we publish in Sloan has a data model. And a data model, yeah, you know what? I'm just going to start from the beginning here. We have a data model structure. And since I'm looking at MaNGA and I was looking at, say, cubes, I can go to Spectral Redux, which is the directory where I am. There we are, MaNGA cube. And that will tell you exactly what is in each different layer of the FITS file, including useful things like what units are the quantities given in. So when you work with Sloan data, I would recommend that you always also look at the data model so that you know exactly what kind of data you are working with. And let me just go back to my presentation again, where you also have a link if you want to look this up in your own time at some point. Now, I will say, for those people amongst you who make SDSS data products, you will have encountered the data model process and how we make data models. You also know that over the years, we found out that some things could probably be a bit more efficient, a little bit more better, like versioning, etc. So Brian and Joel have been working on developing a new system for data models that we're going to use in Sloan 5. If you want to know more about that, we had a code review for that that you can find at this link on the SDSS 5 wiki, but you can also come to the data handout and just ask us all about that. Okay, slide pause. This was the SAS. Let's move on now. You now know where to find your files, you know how to find out what is in your files. But I can also imagine that you then think like, yeah, well, there is a bunch of files here, but before I start downloading them all, I kind of first want to look at them because astronomers like to look at data. What you then should do is make use of the Science Archive web app, where you can look at all the different data products that we have. And I'm just going to walk you through that again. So the Science Archive web app also has its own acronym. It's a SAW. It's available for Apogee data, eBOS data, and for MaSTAR data. If you are in MaNGA, don't worry, we'll have a different app for you, and I'll come to that in a moment. And I am just going to try and show you this again live. And this is actually the part of the talk I most enjoy, because this always forces me to really look into different data products of surveys that I'm a bit less familiar with. So I'm just going to go to infrared and get a bit of Apogee data. There we are. It's loading. It will now give you all the plates, all the spectra observed by Apogee with the different programs, whether that was co-observing in the south, etc. There's a lot of them. I want to, earlier when I looked into this, I found RR-Lear, which I think is RR-Lyrae stars. Apart from knowing that these are variable stars and you can do something distance-like with them, I actually don't know much about these stars. So if there's anyone in the audience here from Apogee who actually works with these stars and wants to say a little bit more about them, please do. I do know, though, that the RR-Lyrae star itself was discovered by a Scottish astronomer, Williamina Fleming, but that is where my knowledge stops. But I just did a search, and I am actually curious to see these ones, which were observed in the south. So I click on the spectrum. Oh, I see from Juna that I made a good choice of Apogee target here. Okay, and you know what? I'm just going to click on the first one. So that was a plate full of Apogee targets. Plot. And I so hope that we're now going to see a spectrum that Juna at least confirms is an RLR star. Ta-da, infrared RLR star.
So Anna-Marie, you've picked
Yes.
the RLR targets are among the these targets are among the targets in SDSS4 that we really pushed the limits of in terms of signal to noise, because we want to get a huge sample and we just want to get radial velocities for these targets. So you can actually see the signal to noise is not huge on these, but that is on purpose. So anyone who is interested in, there are RLR targets that have much higher signal to noise, and those are our template targets. But this is actually one of the programs where we're really pushing the limits of the survey.
Perfect, thank you, Juna. Okay, so higher signal to noise targets available, ask Juna. What I am going to show you though, I just zoomed in a little bit, and what I always love in these apogee spectra is that you have abundance windows that you can show, and then you can just see that carbon is a ridiculous element, or at least that's always my takeaway from these. Okay, but that is one of the things that you can do to just inspect your spectra, see if you're happy with the signal to noise or not, see if you want to do a different selection and then work with that. I did infrared. I'm now going to go optical because why not? And I really want to show you master, because if you are a Sloan 4 member, you can push this button here, which will ask you for a password, but I logged in earlier already because I was prepared, and the DR17 spectra are there already. And I'm now going to show you something slightly different, because again, I also am not really into master. But I did notice WD, which I think is a white dwarf. So just look at those. And I think Boris Gansik is going to give a talk about white dwarfs tomorrow. I'll do a search. And I'm just looking by bit mask, so I can then look at different populations of stars. This one has 5 visits, so let's go for that one. And I hope someone in the chat can confirm that this is indeed a white dwarf spectrum. It looks star-like to me, but please let me know. And another thing that I really like about these, about the SAW, is that if you are collaborating, there is this permalink. So if you want to do a search and you want to share it with a collaborator, you can just click this. And then the search is basically has then an ID number. And if someone else then does that same search, they can confirm that. And Odette, thank you for the information. If people want to look at white dwarfs before Boris' talk, you can use that search over there. Okay, now, this is all for single spectra. What if you are a galaxy person and you like IFU data? In that case, you should go to Marvin. And there will be a workshop later this afternoon, so I'm not going to show too much here. I am just, however, going to show you my favorite plate, just so that you see a little bit of what you can do with Marvin data. I may just have pushed my internet connection to the limit. We just close down the ones I don't need anymore. Yeah, there we are, that helped. Click on your favorite galaxy. Actually, I'm not sure if that was my favorite, but it was there. Map spec view on, again, for that interactive element. It thinks about it. And it means that I can look at different spectra. Here, I can zoom in on them, inspect them a little bit closer. I can also look at different maps, but what Maria is probably going to show you a lot about is that there is also a whole suite of Python tools here for you to analyze your data and that you can use from Marvin. The only thing maybe that I quickly show you, just again to show you how versatile Marvin is that you can also query in Marvin. And if you say, well, I'm not completely sure how to do that, there is actually a query builder where you can, for instance, say, I want all the galaxies that have a redshift less or equal than, I don't know, 0.1. And that is when the whole thing crashed, did it? Yeah, there we go.
Anna, this is your 5-minute warning.
Okay, thank you. I should actually have given them something that I actually wanted to return. So there we go. And you get that search and how to do it in Python. Okay, I think I'll stop demoing now for the time and just go back to my presentation again. And in the last 5 minutes, just talk you a little bit through what else we have. The catalog archive server is the way that you can access your catalogs. And I'm not going to show too much about that here because Jordan is going to do an awesome job of that this afternoon. But I do want to point out here that the public especially uses a lot of the CAS server because we as a server do a lot of work to derive a lot of quantities from our spectra. And therefore the CAS server is actually one of the servers that is very often used by people who say, I want the galaxy mass, I want the redshift, I want the star formation rate. And then we also have size server. Again, there will be demos about that this afternoon, where you can, without having to download any data, analyze the data. And even that now comes with an interactive element there. And Voyagers, I don't need to say anything about because Niall already did that. Okay, so in the last few minutes, and I realize I didn't time this correctly, so let's see how long Mariana lets me talk. Another term that you may have heard quite a bit is a value-added catalog. And these are data products that are not provided by the data reduction pipelines themselves, but that you as scientists actually can access and that you make for yourself to do your own science. And then once you've derived your mass, your rotation period, whatever it is that you calculated, that is a catalog that would be very useful to share with the wider world. So facts are released in public data releases. They must be based on public data. They must have also a publication that explains what the fact is all about. And one of the things that I think we did a pretty good job about in Sloan 5 is that we hopefully made that process of creating a value-added catalog a lot more transparent with having manuals and having an announcement system there. And that means that when we end Sloan 4 in December, we'll have over 60 facts available, while there were only 11 when Sloan 3 ended. And what I particularly like here is that also the people who make value-added catalogs have now become a much more diverse group now that we have all the documentation there to help them. So where before it was mostly data experts who created value-added catalogs, now everyone in the collaboration, whether that's professor, postdoc, graduate, even a vast team of undergraduate students that I was very happy to see, is now creating value-added catalogs. So we definitely want to continue this in SDSS 5. And if you are in SDSS 5, I would really ask you to already start thinking, what is there in your science that would make a good value-added catalog? Who would make use of that? What kind of information needs to be in there? And we will contact you all later this fall with more information about value-added catalogs. And also, if at any time you have questions about this, do please ask us. And if you need computing power, Sloan 5 comes also with a new cluster. And if you are working on SDSS data products, you are able to get access to that cluster. There is a wiki page here that I would encourage you to have a look at to see how you can get an account there. And again, come to the data handout if you want to know more. Mariana, how much time do I have left?
1 minute.
Okay, I'm gonna rush through the public data releases then. you may know that we do a lot of work on public data releases in Sloan, and I'm actually going to just shamelessly refer you to a conference proceeding I wrote where you can read a lot more about that whole process. But in this last minute, I do want to make clear that public data releases are really important to what we do. This is a slide that I inherited from Adam Bolton when I joined the data team. Why we actually do the data releases. They increase the impact of our science, but they also enable reproducibility of our results. They make sure that the data gets well stored and archived. More science is possible, and it's just what we do. And data releases work very well because the public accesses our data quite a lot. This is the number of CAS catalog queries per year per release. And if we think about the SAS, we're talking about 1 to 10 million hits per month. And that corresponds to up to 20 terabytes of data per month that is being downloaded. And that has impact. There are over 8,000 papers published based on Sloan data. And a lot of them come from outside of the collaboration.
That's actually more than 11,000 now.
Wow, this slide was a year old and I thought I was still up to date with that. I'll change that. And over 11,000 papers. We also are known in the community just for having a good way to make data publicly available. Other surveys start to us to ask how we done that. And very recently, we also got an award from SIGMOD for the systems that were developed for SDSS. And also, coming back to Niall's talk, we are also a very reliable source for EPO. And I want to highlight that just last week, the Voyages webpage was recommended by Internet Scout, and I have a link there if you want to know more. So what makes our data releases work? Well, first of all, awesome data, of course. But I think also very important is that we document the data. And this is really one of my pet peeves. Data should not just be available, it should also be accessible. And that means that it needs to be documented. We have data models, we have web pages, we have tutorials, we have examples, but putting that all together is really a team effort and requires a lot of expertise. And also, isn't documentation boring? How do you actually convince the people to document their data products? Well, the answer is to make it fun. So this is a picture of one of our previous documentation festivals. Everyone hard at work, smiling, and not just because I took a camera. But we meet for a week where we just sit down and write down all the documentation that we need for public data release. We try to make it fun because it is just fun. I say this now, to go out for dinners, excursions. This year, however, we did it all online, and I'm really disappointed with the Lama who joined us because he still hasn't submitted the pages that he was supposed to document, but that's for that. I am going to finish now because I see Mariana coming off mute. If you are in Sloan 5, there is lots of awesome new stuff coming your way based on the older systems that we have already there. And really, if you want to know more, if you want to help us out with writing documentation, if you want to make a value-added catalog, just get in contact. And thank you, and sorry for running a little bit over.
Thank you very much, Anne-Marie. Questions, it's time for questions. So of course, ECRs are encouraged to ask. Meanwhile, I can highlight a couple of comments that are shown in the chat. So Hector Ibarra-Medel leaves a link in the Zoom chat for anyone that wants to get access for newly reduced BOSS Black Hole Mapper, Milky Way Mapper data. You can check it there. And Jonathan Trump also says that for more about SDSS 5 data, please go and join the Black Hole Mapper session on Wednesday. Okay, thank you. Yes, of course. If you could post this, your slides on Slack, everybody will appreciate it.
Yeah, I have, I filled in the form, so I assume that means they get uploaded, but I also admit that I did that this morning, so may not have gone through yet, but I'll also post them on Slack.
Thank you. So questions? if there are no questions, it means that everybody knows how to download data. Well, I think it was very clear.
Yeah, and again, there is a data handout
Yes.
later this afternoon. So if there is anything that you try out some of the examples and they don't completely work or you get stuck, just come to the data handout and we'll unstuck you.
Okay, there will be a time for questions live in the data hangout?
Yeah.
Okay,
yeah.
great.
Yeah. The schedule is in the Slack channel that we have. We have an I'll put that in the chat. What is it? What did we call ourselves? Data Workshop 2021. I will just post that in this Slack or in the chat.
Thank you.
And the first part, oh, wait a minute, I did that wrong. And the first part of that is the demos. So definitely, if you want to start using SciServer, Marvin, SkyServer, please come to those to see how you can optimally make use and searching through the data. And after that, we have 45 minutes of just unstructured data time.
Well, thank you. I think our time is up, but Amy Jones posted a very important question in the chat. If you can answer that, thank you. But meanwhile, we have, thank you. Meanwhile, we have to move on to the last speaker of today, who is Mubdi Rahman. Mubdi, could you please share your slides now?
Sure, thanks so much.
Okay, so Mubdi Rahman is the editor of the AAS software journals, who is going to give us a 10-minute announcement about how to submit to AAS software journals. So thank you very much, Mubdi. The floor is yours.
Yeah, thank you so much for having me. And thank you to the organizers for letting me steal a little bit of your time. The Sloan Digital Sky Surveys have a place in my heart. There's a place that I, cut my teeth back when I was in my postdoc. And I know just the quality of the data that comes out, the quality of the science that's being produced, and importantly, the amount and quality of the software that is being produced by everyone on the team, everything from the initial acquisition to the pipelines for reduction, all the way to the final data analysis, and also the interactive tools that are being produced for the community as a whole. You guys have become sort of a fantastic model for how to make data open, how to make science reproducible and accessible. And it's something that the community really, at least as now as an external member, the community really does appreciate. And what I'm here to do is to tell you a little bit about how to get more of this stuff published. So one of the things that we're doing at the AAS journals, so this includes the astrophysical journals, the astronomical journals, and the new planetary science journal, is we have an entire new track of papers called software papers or code papers. So I'm just going to give a little briefer on what these are and maybe encourage everyone to, for the software that you're producing and for the code that you're producing, have this, think about maybe submitting a paper. I'm just going to have the chat open so I can answer any questions that come up, but please feel free to throw questions in the chat as I go along. So let's talk about what a software paper is to begin with. So a software paper is a peer-reviewed paper appearing in one of the AAS journals. So that is AppJ, AJ, AppJ Letters, AppJ Supplement Series, or the Planetary Science Journal. And it describes code or software that has been developed in aid of scientific research. So if you have developed any piece of code or software that is being used for the purpose of scientific research, we would love to see a paper on it, and we would love to be able to publish a paper on it for you. So what does that actually mean? So what is a software paper not? Because there's often a couple of misconceptions about what we mean by a software paper. So first off, a software paper is not the documentation of your software. I mean, the Sloan software tools have fantastic, doc pages that people can go to. And I'm sure a lot of the analysis pipelines and the pipelines that are used to create value-added catalogs, they have these fantastic documentation. We're not trying to replace that with a software paper. What we're trying to do is give you a place to actually talk about the science and promote the software itself. Secondly, it's not a requirement for you to forever maintain or support the code you develop. That's one of the things that we definitely see. And it's a reasonable fear that if you've made something, you release it out to the public in the community, you'll be asked 20 years later to support it or to try to debug some random Fortran 77 issue when you've even forgotten all about that. So that's not what this is about. This is basically not a commitment for forever development and but it is a way of getting people to know about your software. It's not even a requirement for you to publish the code, even though we do think code publishing is a good idea, and we are very much in favor and support of open source. But you are not required to publish your source to publish a software paper on that code itself. It's also not necessarily a statement of how important your code is, and it doesn't mean your code is perfect, because that's the other big hangups that we often see when people are talking about software that is being produced or code that's being produced to produce very important scientific results. There's a sense that, oh, my code's not perfect. I haven't commented every other line. I haven't, put it through X number of checks. That's not what we're talking about. We don't expect your code to be perfect. And in the sciences, in general, we know that code evolves and the software tools evolve. And so we want to create papers that reflect that. Okay, so why should you publish a software paper? Some obvious reasons here are to make sure you get the credit for everyone who's involved in the development. And that's a big important part. There is a huge team, especially within the Sloan community, that are doing a lot of heavy lifting in building these tools that the entire community uses. And a software paper is a fantastic way to make sure the people who are doing that hard work get the credit for it. And so we certainly want to encourage people who are working on active software that especially much of the astronomy community depends on, get the credit they deserve. Secondly, it's really useful to validate the science in your code. You're getting a peer review, you're putting out the ideas behind the software in a paper that will be available to the community. And it gives you a sense of having somebody else who's not necessarily a part of your collaboration take a look at the code or take a look at the science within your code and be able to give reasonable comments on it. Thirdly, we want, this is an awesome opportunity to show off the cool software that you've developed. And this is a big thing, especially for early career researchers who are, starting to get into the kinds of science they want to do, the kinds of development they want to do. And this, oftentimes there'll be a lot of software work before you get to a, scientific result. This is a good way of getting that software work out and show off, some of the fun things that you've been able to do already. Another reason that you want to do this is finding members of the community that, to use and find that code that you've built, because, there's nothing demoralizing as putting something out on on GitHub, expecting everyone to use your fantastic new, way of determining, some fitting function, and then suddenly no one uses it because no one knows about it. And so this is a great way of getting people to more know about the code that you're using. And finally, to inspire other researchers with the methods, both the software and the scientific methods that you're developing. So in all of this, the science begets science. And so the tools that you're developing, the algorithms that you're developing will potentially produce new tools and new algorithms that will just push forward, the edges of what we're able to do in astronomy. So I talked a little bit around with this idea, but what does the software paper actually look like? And so this is one that's a little more flexible because there's no one size fits all. For a very in-depth pipeline paper that talks a lot about, how to get data from a detector to a usable, database entry, that will be a very different paper than an analysis code that just takes, a bunch of different, images of a file and produces some fitting law or something along those lines. But basically, generally speaking, you'd want to answer the following questions within a software paper. First off, what's the challenge that the software seeks to address? Secondly, how have you technically implemented this? Thirdly, what scientific choices have been made in the software? Fourth, how do you actually use the software and code? And 5, what's an example of a use case of the software and code? And if that's sounding like a fairly small paper, it can be, right? This is what we're trying to do. We're trying to encourage people to produce papers that don't take a lot of effort inherently to write, because the software is actually where you put the effort, but help get your software out and your code out there. And the key thing that we want to highlight is that the audience for these papers is other astronomers like yourselves, not computer scientists. They're not going to be going into the depth of how you did your fitting algorithm or what your, how, the input and output could be optimized. That's not who we're talking about. We're talking about getting it used by other astronomers. So when should I publish a software paper? That's a natural, obvious second question there. So the thing I would say is that if your code or software is important to publishable research at the moment, it doesn't have to be published research, publishable, it's ready for a software paper. And that highlights the key that your code does not need to be final or perfect to merit a software paper. If it's being used out there for research, it's ready for a software paper. You can put that paper for it. But you might ask, hey, Mubdi, my code is evolving, right? Why, my software is, I'm going to change that algorithm a lot. I'm going to optimize it. I'm going to add new features to it. So this is one of the cool things that we've added on the AAS journals, which is a thing called a living paper. So living papers are papers where that can be updated and added onto you. You can't remove things from it, but you can add additional sections or versions to it, where you can add new co-authors. For instance, you have new developers, you can add that, and every additional version can be specifically cited. And the additions to each version get refereed as well. So if you're thinking that you're starting a piece of software, you're starting a coding project where a lot of people are joining, and you eventually want a larger collaboration to be a part of, this shouldn't stop you from producing a software paper, because what we're allowing you to do is to actually go through and update that paper. And each of those gets its own identifier, and you can cite each one individually. And it just makes the community a bigger thing for you. So living papers are something that we are doing here at the AAS journals.
Mubdi, this is
Yeah.
your 1 minute warning.
Perfect, just about done. So one of the value addeds I'll add is if you publish a software paper with the AAS, one of the things that we're helping you do is to also publish the code on the Journal of Open Source Software. So the Journal of Open Source Software is an online journal that validates and reviews and publishes the code for you. So if that's something that you're interested in, having your code validated by somebody who knows what to look for and to make sure it's accessible, that's something that we're doing. And one of the big things that we're doing as a partnership between the American Astronomical Society and the Journal of Open Source Software is that for every piece of code that goes through and gets submitted to a software paper, as well as the Journal of Open Source Software, they actually get some financial funding from the AAS to help their mission, help support the processing of their paper. But finally, what I'd like to say is that we're here to help. So want to know if you should publish a software paper or have any questions about how to structure your paper. We're happy on the AAS editorial team to set up questions or to set up a consultation meeting and to answer any questions that you might have. So I'm leaving my email address and my Twitter handle here, but feel free to contact me and reach out if this is something that you want to do, or you're interested in making some of the tools that you've developed for some of the breakthrough science that you've done as a team, and having these turn into papers themselves. So thank you very much.
Thank you very much, Mubdi. This was very helpful. So we have time for a couple of questions. ECRs are encouraged to ask.
I see some love in the chat for JOS. JOS is fantastic, and I'd strongly recommend people to take a look at it.
Okay, thank you. Questions? Well, maybe people is already tired for the long session.
Understandably.
Okay, thank you. Oh, good. We have one question. So what is the benefit to go through the AAS publication instead of just directly?
Okay, so basically it's two different things. So AAS publications will produce a paper. So you'll actually have a paper that you can go onto ADS and download, and there'll be actual text. JOS doesn't produce a paper, it just validates your code and gives you a versioned, peer-reviewed version of that code. So this way, if you go through AAS and Josh, you get both. You get a paper that people can read and cite, in their own papers in their archive, but also your code gets validated as well.
Thank you. Well, unless there is one final question, I'm pretty sure people who have questions can contact directly Mubdi through his email and Twitter. Thank you very much. Well, thank you very much, Mubdi.
Thank you so much
for your presentation. Okay, so now we will have an announcement by Ted.
Thanks, Mariana and Odette, for chairing. That's great. And thanks for all the speakers for their lovely talks. So yeah, just a quick announcement. We're going to have a break now for 15 minutes. And hopefully everyone will rejoin us at 12 noon EDT for the third day of lightning talks. And then so that's going to kick off the rest of our own conference day. So we're looking forward to seeing you then. So thanks everyone, and see you in a minute.
Thanks. And I will leave the meeting open during the 10-minute break.